Hi, everyone. And thanks to Maggie and the rest of the wonderful team at Acrew Data for having us today. I'm sorry this will be a recording, but our team is based in Singapore and we're trying to keep a healthy schedule. Just kidding. Obviously, working in data engineering, we're quite nocturnal, but we just wanted to save you from our late night faces, okay? In any case, let's get started. My name is Alex. I work on the data platform product team here at Grab. And together with my teammates, Amanda and Harvey, today we're going to tell you about our journey to improve data discoverability with computational data governance here at Grab. But first, for those of you who do not know, Grab is the leading super app in Southeast Asia. We operate across 8 countries in the region: Malaysia, Indonesia, Singapore, Thailand, Vietnam, Myanmar, Cambodia, and the Philippines. We are the everyday everything hub that combines mobility, deliveries, and financial services across a vibrant and diverse region of nearly 700 million people. Our large consumer base and the multiple lines of business generate a huge volume of data. And all Grabbers use data on a daily basis to make decisions or to augment our systems with data. The longer it takes for the right data to be discovered, the bigger the missed opportunity for us to generate value back into our marketplace. Hence, the criticality of metadata management, which we're broadly breaking up into the very intertwined data discoverability and data governance. In order to cater for this, and after evaluating multiple options, in 2021, we decided to invest in DataHub for 3 main reasons. First, the autonomy and flexibility to customize it according to the needs of the data community here at Grab and the specifics of our data infrastructure. Second, the maturity of the technology and the advanced metadata architecture. And third and potentially foremost, the amazing community behind DataHub that is driving the solution forward. I'll be surprised if there is another metadata management solution out there that has almost 5,000 people behind it. With that, let me pass it over to Harvey and Amanda for the more interesting and practical part of today's talk. Thank you.
Thanks, Alex, for the intro. Indeed, DataHub is so extensible with a strong community at the back that is pushing towards the forefront of metadata management. At Grab, we fought the DataHub repo and we rebranded it as Hubble. Since DataHub was deployed at Grab a few months ago, tens of releases have been made internally. We established a streamlined release process to ensure we have an easy way to merge our code changes with DataHub new releases. Our release cadence closely follows the community one. Each release is rebased against a recent community version with additional features developed internally at Grab. Some of those have been contributed back to the community. Next, Amanda and I will highlight some features that we extend from DataHub for data discovery and data governance use cases. Let me start off with data discovery. With big data comes big metadata. Scalability has been rarely an issue for DataHub. To date, we ingest 3.5 million metadata change proposals to GMS either synchronously or asynchronously on a daily basis. That translates to around 40 MCPs per second. We managed to ingest metadata for over 100,000 tables within 15 minutes with parallelism in place using Presto on Hive plugin, which has now been open sourced. We also created additional entities and aspects to the metadata graph, one of which is a generic entity type. We call it others to cover custom entities at Grab. I'll share more later too. Here, I'd like to share how we scale Hive ingestion to reduce ingestion time from over 20 hours using original Hive plugin to 15 minutes with a new plugin that we initially developed called Presto on Hive. From the original Hive plugin, metadata is fetched by looking through every schema, table, and view. If there are X schemas, Y tables, and Z views, there will be in total X plus Y plus Z described queries sent to Hive Server 2. To parallelize the ingestion, there's no effective way to shut new and existing tables as well. So instead of connecting to Hive service, we fetch metadata directly from Hive Metastore DB. We sharding to achieve ingestion in parallel. Now, instead of using X plus Y plus Z queries as we saw when using Hive plugin, it only requires 3 queries to fetch metadata for schemas, tables, and views. With multiple parallel tasks running, we use modular operation on the MD5 hash of the schema, table, or view name to determine which task ID the schema, table, or view will be ingested from. I'm glad to share that Presto on Hive plugin has been open sourced since DataHub release 0833. Since then, we saw many community contributors that have been making incredible improvements to it. One of my favorite in DataHub is its super extensible metadata model, where you just need to define the PDL schema and update the entity registry to add a new entity or aspect. And everything else is then taken care of with AutoCodeGen. Next, I'd like to highlight 2 examples we did on this front. First is on the dataset entity. We added a time series aspect to support sample events for Kafka topics. This feature creates tremendous value for our users, as they now can just go to DataHub and view the sample events without requesting data access to the Kafka stream itself for discovery purpose. As more use cases are onboarded, we often have to make a judgment call on whether to reuse some existing entity, add new aspects to an existing entity, or to create a new entity in the metadata model. The current subtypes aspect augments the extensibility of an entity type. For example, we can model table view, topic, or add datasets in DataHub. However, there are occasions when some entities are very bespoke to internal data platforms. As such, we create a generic entity called Others in DataHub to cater to all these unique groups of use cases. It has an aspect for generic properties that support different rendering types, so that a property can be rendered as table, string, code, or JSON in the UI. In the screenshot here, what you see is an other entity with a subtype name called Skywalker MOG. Those are entities for Grab's content ranking platform. In short, DataHub's plugin-based ingestion framework and schema-first metadata model are what empowers us to make data discovery democratized across all sorts of entities. In addition to data discovery, we also use it to facilitate computational data governance. I'll now pass it over to Amanda to share more about that.
Thanks, Harvey. I will now be going through data governance in Grab. Data in Grab is extremely valuable as it forms the foundation of many of our critical systems and operations. So we really need to establish our data as something governed while delivering the greatest value and agility of these data. At Grab, data governance anchors on 3 main points. Firstly, data is immensely valuable to Grab. Great data unlocks great growth, encouraging innovations, improving operations, and the quality of our products. Secondly, data management is democratized. At Grab, there's no single role or department that owns every aspect of the data. It cannot be seen or treated in isolation, but as something that everyone in the company may be consuming from to make important decisions. Everybody in the company should be able to work with the data comfortably and confidently. And lastly, data must be agile. We need it to be at the right place and at the right time. We want it to be accessible, to have it self-served, and to enable everyone at Grab to answer questions without having to ask someone else. And because of the tech mindset at Grab, we don't want to introduce new processes. So we built on top of the easily extensible DataHub to enable our organization to use data in a governed way without introducing overheads to the organization. Information classification in Grab is a process where the owners identify the sensitivity level of the company's information to apply an appropriate level of protection to the information as it's created, updated, stored, transmitted, or deleted. The level of sensitivity would affect the user's access to the corresponding data. Prior to DataHub, we were relying on an enterprise software to help manage sensitivity levels, and customizations were extremely limited. So all we could do is to guide users through documentations and relying on them to infer and conclude the data sensitivity level. This manual work led to a lot of invalid classifications against the organizational rules. For instance, the table wasn't tagged as containing PII when the column is tagged as containing PII, which then led to several rounds of organizational-wide campaigns from our governance and cybersecurity teams to manually validate these rules across hundreds of schemas and the 100,000 tables within. This was incredibly taxing for the team, taking up a huge number of man-hours to go through them. DataHub enabled Grab to take this number down to 0. So how do we take that number down to 0? We modeled such metadata into glossary terms and notes. We added validations on the React application and on the entity service within GMS. These allowed the validation errors to be displayed both to the users using the user interface to update and to any external services ingesting these rules directly into DataHub. In this demo, you can see an attempt to set the sensitivity level of a table when the column has been tagged as PII. Having these validations shown up front allowed users to self-serve, and at the same time, they were also actively getting informed about the policy requirements within Grab. So we have talked about creating these information classification, and the next topic is how we would determine who should own these access controls. In Grab, we define these decision makers as technical data owners. These are individuals who are accountable for security access controls of the data sets they manage at a schema or database level. And as the role of the technical data owner for the schema isn't trivial, like granting access to possibly hundreds of tables at one go, we have to enforce that this person meets the minimum requirements set out by our data governance office. And considering that this seems to be a highly specific and customized piece of logic, we then decided to use the DataHub Actions Framework. The DataHub Actions Framework allowed us to read only the events we need. In this case, it's ownerships for schemas when there's a change to the technical data owner. From there, we could fire a request to a separate Grab internal service to validate these owners and make follow-up changes when we need it. And as such, we've also went the additional step to help the users automatically roll up to the appropriate owner if he or she doesn't meet the minimum requirements. And in this snippet, you can see that adding me, Amanda, as a technical data owner results in a Slack message being sent. And when the page gets refreshed, it gets reassigned to Harvey. And with these two customizations in place, we have ensured that the flow for data access is governed. And with that, we've come to the end of our presentation. All this is possible thanks to the amazing team working on Hubble and the support from the DataHub community. We'd also like to thank DataHub for inviting us to present, and we are looking forward to further collaborations. Thank you.